Welcome, and thank you for joining me for this 1-4A lesson. So in this lesson, we're going to cover a wide variety of topics that kind of review much of the things that you learned back in Algebra 1. Those things range from, we're going to cover combining like terms, evaluating expressions, solving equations, all the way up to solving word problems by writing equations and expressions. Now, a lot of algebra consists of finding real-world situations, making equations to understand them, and then solving those equations. So by the end of this course, you're going to see things like how to solve this, which actually should be familiar. You have seen it before. Same thing with that, you'll be able to solve. And then even some new ones that you've never seen, even back in Algebra 1. So that's kind of the end game, just to show you where we're going. Throughout this course, we're going to be solving a wide variety of equations. Now, what does that look like for us, though, in this first section? Well, before we dive into those more complicated ones, I really want to take a step back and see, well, do we remember how to solve basic equations? So today, we're just going to talk about solving linear equations, okay? Linear equations really just means it has a normal x in it. Okay, now of course things are going to be happening to the x. And the goal when we're solving an equation is we're going to focus on undoing all of those things that are being done to x to try to get x by itself. Okay, so let's take a look at what that means. So in this first one, I'm going to be talking about this one right there. If I'm looking to undo everything being done to the x, well, the first thing that's the easiest is anything that's actually not directly connected to the x. So if you notice that plus 1 by it isn't actually directly connected to the x, so I'm actually going to undo that first. How would I undo addition? Well, I'm going to subtract it. So that's going to leave me negative x over 4 equals negative 2 minus another 1. That's going to give me a negative 3. All right, so next thing being done to the x, you can see, is being divided by 4, right? So again, what I'm going to want to do is I'm going to want to undo that. To undo division, I'm going to just multiply both sides by 4. So if I multiply both sides by 4, it cancels off the 4 that was there, obviously. And negative 3 times 4 gives me negative 12. And then finally, that negative in front of the x. Well, if negative x equals negative 12, well, you could just be like, well, obviously just reverse that. X is going to be positive 12. Really what's happening is there is a negative 1 connected to the x. So you could also think of kind of dividing off that negative, okay? Dividing both sides by negative 1, and that is going to give you positive 12. Now, the really cool thing, and I know all of you math teachers have probably emphasized this in the past, the cool thing is you can always go back and check your work when you're dealing with equations, because I can plug that 12 in to make sure that it makes sense, okay? So I'm going to go back now, and I'm going to plug in that 12 in, oh, I apologize, into that original equation, and I'm going to make sure that it makes sense, okay? I'm going to see if I get a true equation back. Well, to start with, this kind of order of operations, I'm going to do negative 12 divided by 4. I'm going to start with that division, and that is going to give me negative 3. Well, negative 3 plus 1, that's going to give me negative 2, and you can see, yes, it does check out. I do have the right equation, or sorry, the right solution. Okay, so that's a key component. Once you solve it, always a good idea. Go back and check it because you're going to be so much more confident you've done it right if you go back and you prove it to yourself. Now, I want to show you the difference from what we just did compared to the example that I have on the right. Okay? So I want to make sure you understand the order that these things happen in, right? Math happens in a process and an order. Now notice here, the first time I talked about it's easiest to undo things that are completely disconnected from the x, right? But this time notice that plus 1, this time it's actually connected to the x because that entire thing is being divided by 4, okay? So this time it's a little bit of a different situation. That whole side of the equation is being connected by that 4. So I can't separate that 1 first. So what I'm going to have to do is this time I'm actually going to deal with that 4 first, okay? I'm going to move it away from that x right away. So here my first move, multiply that 4 over. Okay, so it cancels off the 4 from the side it's on, multiply it over, so obviously negative 2 times 4 is going to give us negative 8. Now I'm free to deal with that plus 1, right? Now that plus 1 isn't connected to my x at all, so now I'm free to subtract that off. So I'm going to have negative x equals negative 8 minus another 1. It's going to give me negative 9. And then just like before, I'm interested in x, not negative x. So I'm just going to think I can take off both of those signs. Or again, mathematically what's happening is I'm dividing both sides by negative 1 to remove those negatives. And I get x equals 9. Again, the power of being able to check your work is I'm going to go back. I'm going to convince myself I have this right by putting the 9 right there. So when I do that, I get negative 9 plus 1 all over 4 equals negative 2. This time I have to deal with the whole top of the fraction first because it's just one ginormous fraction. So negative 9 plus 1 is going to give me negative 8. Negative 8 divided by 4 is in fact negative 2, and you'll see that you did do it right, okay? When you plugged it in, you ended up getting something that's true, so we have the right answer. Okay, so let's look at another pair of problems to make sure we know how to tell the difference between them. All right, so left-hand side. Again, I talked about this idea that you're trying to move everything away from the x, get x by itself. And so it's easiest to move things that aren't connected to it at all. And notice in this circumstance, the negative 3 is not connected to my x whatsoever. So in this instance, I can very easily just add that 3 over. Okay, so now negative 3 plus 3 on both sides, well, now there's nothing left over here because it cancels both of those negative 3's. So I have 2x equals 0. Now, sometimes kids panic when they see this because they get nervous about that 0 being there. However, I'm still taking x by itself, right? So if I'm trying to get x alone, well, 2 is multiplying my x, so to get it away from it, I would divide by it. Well, the cool thing is 0 divided by anything is actually a legitimate answer. 0 divided by 2, 0 divided by 3, by anything is still 0. Okay, so here you actually do get a legitimate solution of 0. Don't panic, that does happen. Okay, I know a lot of kids in the past have gotten a little bit nervous about that. And of course, I can check my work. So I plug in 0 for x. Well, 2 times 0 just kind of drops itself off. And look, once again, I'm left with a true statement. All right. So, again, let's compare a very similar example and notice how it's different. This time, notice that negative 3 is connected to my x, okay, within that parenthesis. So I can't simply add that 3 over first like we did before. Now, I'm hoping, again, I know you've seen this skill for quite a few years now. I'm hoping whenever you see a number in front of parentheses, I'm hoping that your first thought is going to be the distributive property, okay? So whenever you have this situation, a number in front of parentheses, you can clean it up a little bit first by simply distributing that 2 within. So remember what that does, it multiplies both of those things by 2. And now the point that we're at looks just like the beginning of the other one. This is stuff that you're very comfortable with. Okay, so at this point is when we'd add the 6 over. Negative 3 plus 6 just leaves you with a positive 3. And then you would divide by 2. So x equals 3 halves. And of course, as I've been stressing, always a very good idea. Go back, plug it in, check to make sure you are confident in that answer. All right, and of course, order for operations, say do anything that's in a parenthesis or grouping symbol first. So the first thing I'm going to do is this 3 halves minus 3. And remember, 3 halves is basically 1.5. Now for this, feel free if you need to whip out your calculator. That is totally fine. Okay? So here, 1.5 minus 3 is going to leave me with a negative 1.5. If you take negative 1.5, multiply that by 2, you are going to get negative 3 back. And notice we have yet another true statement, meaning we did actually find the correct answer. So these are the basics when we're talking about solving equations. Now, of course, it can get a little bit messier, and I've already kind of alluded to some of the things that you have to do. Now, when you have equations that are messier, it is important that you kind of clean up both sides first. Cleaning up both sides first kind of entails two things. First, whenever possible, we've already talked about distributing. All right, so notice here this negative 2. The first thing I'm going to do is I'm going to distribute that in. So that's going to give me a negative 2y plus 2. Notice you multiply two negatives and it turns positive. And the other thing is combining like terms. So notice on the right-hand side of this equation, notice the 2 and the 3. They can go together, right? Because both of them are just normal numbers. So the process of putting those two together is called combining like terms. Okay? So the first thing I would do whenever you have one that's messier, always get it to just kind of one side, or sorry, not one side. Clean up both sides. Now, now the focus is, notice you have two y's in here. Okay? So obviously that won't do. If we're trying to solve for y, there better only be one of them. So in here, we have to add or subtract off one of those y's to combine it to the other. So in this case, what that's going to look like is if I add this 2y over, if I add that over, now this is a 1y plus 2y. Now I simply have a 3y on a single side of the equation. And that's going to be a whole lot easier because now I can finish solving. Because now I have something that looks like what I just did on the previous slide. What can I do? Well, I can add that 13 over. Sorry, I'm running out of room, so I'm going to bop over here. From here, divide by 3. And you get that y is 6. Now, I'm not going to do it every time just for the sake of the video. But again, do keep in mind, you can plug that 6 in and you can double check to make sure that you get a true statement when you plug 6 in for both of those y's in the original equation. Okay. Again, time-wise, I'm not going to do that for every example because otherwise this video is going to get absolutely ginormous. So that is all the basics of solving. And again, I know you guys have seen that for years now, okay? Probably since the 8th grade, I would say. Now I do also want to review a situation of what happens when the variable cancels out, because that's pretty weird. So let's take a look. Now remember my hint. whenever you're starting with something and that looks really nasty, the first thing I would do is I would go and clean it up. Distribute, combine like terms, all of that good stuff. So I'm going to distribute that 3. I'm going to distribute the -2. And yes, the negative goes with it. Okay. So I distributed. Now let's focus on combining our like terms on both sides. So here, this 6x minus 2x will leave me 4x. 3 minus 10 will leave me -7. 1x plus 3 more x will be 4x. And then I have plus 7. So again, notice just how much more manageable this looks by simply removing that right away, okay? By simply combining everything, cleaning it up right away. So now notice I have my variable on both sides of the equation again. So what I'm going to do is I'm going to get rid of it. So I can get rid of it by subtracting 4x from there. Well, I need to do that on both sides. Well, unfortunately, since it was the same thing on both sides, now it's absolutely gone. Okay? And in this instance, when it's absolutely gone, well, now I'm just left with nonsense. -7 clearly can't equal 7. So that's where this comes in, this no solution. Okay? Because you are left behind, the variable canceled out, and you are left behind with something that is nonsense. So that means no matter what x you originally choose, never going to work. You can never get that equation to work. So let's try the other one. So the other side, or the other one, the right-hand side, I don't see any distributing I need to do, but I do have some terms I can combine. Okay, so I combine my like terms. Again, I notice, oh, my variable's on both sides. Let's take care of that. I'm going to remove this one, but I have to do the same thing to both sides. Ooh. Oh, I'm sorry, that should have been an X. I apologize. So now we have the situation of same thing. The variable is now absolutely gone. But this time, notice I'm left with something true. 5 is 5. So what that's telling me is actually it doesn't matter what x that I pick. Okay? It doesn't matter because it's always going to be true. So we call that is infinitely many solutions. Any x that you pick would make a true solution, would make it work. So this one has an infinite amount of solutions, okay? So again, just a quick review on what it looks like if the variable cancels out of the equation and you're left with just numbers, okay? False means no solution, something true means infinitely many solutions. So next page, really quick, we're going to do a word problem, we're going to evaluate something, and then we're going to call it good. So flower carpets incorporate hundreds of thousands of brightly colored flowers, as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from the Grand Palace in Brussels, Belgium, has a length that is 3 times its width. And it has a perimeter of 200 meters. And they want to know what are the dimensions of this giant flower carpet. So they're describing things in words. And we need to equate that into a mathematical equation. Now, whenever there's something we don't know, so here we don't know the length or the width. Well, whenever there's things we don't know, we usually represent it with a variable, with an x, okay? Now, we know something about the length. The length is 3 times the width. We literally know nothing about the width, right? So the width is what I'm going to start with. So x represents the width because, again, legitimately, we know nothing about it. However, the length we do know something about. The length, it tells me right here, The length is 3 times that width. All right, well, if the length is 3 times the width, and I'm calling the width x, the length is going to have to be 3 times x. Okay? So that's really cool thing here is I can relate the two sides with that x that I literally just defined. So what's the next clue that I can pull out of here? Well, the next clue, it talks about having a perimeter of 200 meters. Perimeter, hopefully you remember that from geometry. So perimeter is going to be the distance around the object. Okay? So here what that means is I have another x on that side, another 3x on that side, and it's the sum of that entire way around. So if I'm making an equation, I have to add up all 4 of those sides. And what does that equal? Well, it tells me that it equals 200. Okay? So, knowing that that equals 200, having this equation, well, now I can actually solve it for x, like all those equations on the previous 2 slides. 3x plus 1x plus another 3x plus another 1x. So that's going to give us 8x equals 200. And then, of course, divide by 8. X is going to equal 25 meters. Okay. Now, to answer the question, it asks for the dimensions. There is no x in my question. So the dimensions of this thing, if you think, well, if the width is 25 meters and the length is 3 times that, the length has to be 75 meters. So here when it's asking for the dimensions, keep in mind it actually does want both, okay? Don't just stop at the one, please. All right, again, I know this is getting a little bit long, so evaluating expression. So evaluating, all that means is you're going to be plugging a number in. You actually already have some experience with this. When you're checking the solution to your equation, you're evaluating a piece of that, right? Evaluating means you're substituting in, okay? Whenever you're substituting something in, a number in, I do want you using parentheses, okay? It's going to make your life a whole lot easier, as you're going to see in this next example if you do that. Another thing is you probably have already realized that everything has an order. And if you remember from middle school, or even algebra or geometry, actually all of them, the order is going to be PEMDAS, parentheses, exponents, multiplication with division, addition with subtraction. So when I'm evaluating, again, the biggest thing is using your parentheses, okay? So I'm going to go through. I'm going to plug in 3 where I see x, 1/2 where I see y. Again, whenever I do that, I am going to use parentheses around them, okay? And again, according to order of operations, the first things you deal with are parentheses, okay? So notice these parentheses that I just created, not really important, right? I'm talking about, remember these parentheses were here from the beginning? So that's kind of what I want to deal with first, right? I want to deal with this because it says deal with anything inside of a parenthesis. Well, even inside that parenthesis, I see some things happening. I see subtraction and I see multiplication. But if you notice, multiplication is faster on that list for PEMDAS, so that's what I'm going to do first. So I'm going to do the 2 times 3 times 1/2 because multiplication as a chain just happens left to right. 2 times 3 is 6 times 1/2, so that's going to give me 3 again. So really in here we have 5 minus 3, or that's going to give us 2. So I'm going to simplify that whole parenthesis to just a 2. So I forgot the minus 1. Okay, so I dealt with my parenthesis that was there in the original problem. Now I'm going to deal with E, exponents. So here, notice I do have an exponent, right? That's squared. The squared is only affecting that 3, right? So 3 squared. So right away, I'm going to change that to a 9. Next on my list, multiplication slash division. Now there is division in this problem, but notice when it's dividing the whole thing, the top is grouped together to be dealt with first, okay? So here, that's why I'm only going to focus on the multiplication of the top. Whenever you're dealing with one giant fraction, you have to deal with the entire numerator first, entire denominator first, and then see what happens. So here, I'm just going to focus on multiplying across the top. So 4 times 9 is 36. 3 times 2 is 6, minus 1. All right. Addition slash subtraction. And again, when it's a chain of this, it just is going to happen left to right. 36 plus 6 is 42, minus 1, 41. So here we have 41 halves, or that would be 20.5, okay? You can write it either way. When it's a fraction that will give you a nice decimal answer, you may turn it into a decimal. If it's something like 1/3, please don't write that as 0.33. They're not quite the same thing. Just leave it as a fraction in that case. But yes, so PEMDAS, huge deal. You are going to have to make sure you're really good at that still. But then you've had a lot of practice. So that is the end of our notes here. So for your summaries, this time, why don't you wait till you're back with me in class? I will model how to make a good summary with you. Okay, it's not going to be in the video. You'll do it with me so we can have a conversation about it. So this is it. So thank you for joining me for this video, this recap of some of the important Algebra 1 skills. So come back to class ready to do your practice work. And again, thank you for joining me.